Hello, so today we're going to look at the history of the atom. So the previous video looked at the structure of the atom, looking at our protons, neutrons in our nucleus and our electrons orbiting around it in shells. We're going to look today at how scientists came to those conclusions and those theories. So please make sure that any other tabs on your computer are closed and that your phone is switched off and put away. So our story starts in around 500 BC. We are in ancient Greece with a philosopher called Democritus. Now, Democritus decided that all matter was made up of tiny particles called atoms. So we have a tree. If we were to look in at the tree according to Democritus, we would go in and we would find that all matter is made of these tiny particles called atoms. And this gave us the atomic theory. So all matter is made up of these tiny things called atoms. We're now going to go forward about 2,500 years into the 1800s, where we have this lovely chap here called John Dalton. And John Dalton was the first person to sort of build on Democritus's ideas that all particles are made of atoms, and we still have these nice spherical balls, which we like drawing because they're nice and easy to draw. But instead of all atoms being identical, he decided that actually different elements were made up of different atoms. So different elements had different atoms. So we might have an oxygen atom, we might have a sodium atom, we could have a nitrogen atom, a hydrogen atom, and they are all different. We go forward to the end of the 19th century to 1897, and we come across this guy called J Thompson. There he is, lovely chap. Started the trend of a lot of scientists having a moustache. And J Thompson had discovered the electron. And he realised that actually our atoms weren't indivisible, they were actually made up of different parts. He realised the electron had a negative charge. And obviously realising as well that our atoms, as they are naturally, are neutral. They have no overall charge. So to counteract this, he realised the atom must have a positive part as well. So he developed his plum pudding model. Plum pudding was very popular in Victorian times, which is why the name stuck. And for that, we have a ball of positive charge, or a sphere of positive charge. Inside that sphere, we have little electrons dotted within it, just like the plums in a plum pudding. So we have electrons inside our sphere of positive charge. So we go forwards a few years to 1908, and we have this chap called Ernest Rutherford. Ernest Rutherford was born in New Zealand, but moved over to Britain to study physics. There he is there. And he, along with some of his students, did an experiment using a very thin sheet of gold, and they fired some positive particles at it. Those positive particles we now know to be an alpha particle, or the helium nucleus. And they fired them at them, and they put a detector on the other side to see how many came through. Now, if Thomson's model had been correct, they were expecting all of them to pass through. And indeed, some of them did pass through. They went straight through and got detected. In fact, a lot of them went straight through and got detected. Some of them, however, got deflected off at a very strange angle. And some of them, instead of being deflected off, just came straight back the way they went. And this confused them. So they decided to try and work out what was going on. So Rutherford came to the conclusion that atoms are empty space. Or they're mainly empty space. There's nothing in them. They have a small, very small, positive nucleus. And they have electrons will orbit the nucleus. We call this our nuclear model. So we have a positive nucleus and we had the electrons going around the outside. And he was pretty happy with this. Now, a few years later, in 1911, we had a Danish scientist called Niels Bohr. Now he's there, started not having a moustache now, and he did a bit of work on Rutherford's theory of his nuclear model and realised that actually instead of our electrons just going around in no particular order, that the electrons would orbit in shells or in energy levels. And that's where we start getting our 288 from. So if we looked at, we'll look at calcium, we have our 2 electrons on the first bit, and then we get more electrons as we go around and we increase in energy levels. We now come forwards to 1932 with this guy called James Chadwick. There he is there, again, no moustache. And James Chadwick discovered the neutron. Now you may be thinking, how do all of the protons within an atom stay together when they're positively charged and they should repel each other? It's all because of the neutrons. So our neutrons hold the nucleus together. Something called the strong nuclear force. It's this force and this amount of energy that's in there that led to atomic bombs. So we were able to split atoms and release all of that energy. So here we have our scientists. We have a whole line of scientists that all built upon the ideas of each other. We started out with our atomic theory, where we just have atoms all in together. We moved on to Dalton's atomic theory, where actually we realised we had different types of atoms depending on the element. We moved on to Thompson, where we have the plum pudding model, where we had a ball of positive charge with negative electrons embedded in it like plums. We then moved on to the nuclear model, where we have a positive nucleus and then electrons all going around the outside and just whizzing around it. We then moved on to Niels Bohr, which moves on to improving the nuclear model with having energy shells for our electrons. And we have our nucleus, and then we have 2 electrons, and then our next 8 electrons, and so on. Finally, we moved on to Chadwick, who discovered our neutrons and found out that we had our positive protons in the middle and our neutrally charged neutrons as well, along with our negative electrons orbiting the outside. And this is important because it shows us how scientists make those discoveries. They've all had to build on the ideas of people that have come before them. James Chadwick, right at the end, couldn't have come up with his idea of neutrons or discovered the neutrons without all of these people working before him. I hope you found the video informative. Please do have a go at answering the questions and don't forget to subscribe to the channel. Have a great day.